Hello, welcome to Fogwing Learning Center. Today, we will be discussing about failure prediction with machine learning. Let's jump right into it. In today's fast-paced, data-driven world, minimizing downtime and ensuring the smooth operation of equipment is crucial for businesses across industries. Predictive maintenance has emerged as a vital strategy in this context, using advanced technologies to anticipate equipment failures before they occur. One of the most effective tools in this strategy is machine learning, ML. Let's dive into how ML is transforming failure prediction and reshaping the future of maintenance. What is failure prediction? Failure prediction refers to the process of using data to foresee when a machine or system is likely to fail. Traditionally, companies relied on reactive maintenance, where issues were fixed after they occurred. This led to costly downtimes, repair expenses, and lost productivity. Preventive maintenance improved upon this by scheduling maintenance at regular intervals, but it could still be inefficient, leading to unnecessary maintenance actions. This is where predictive maintenance comes in. How does machine learning enhance failure prediction? Machine learning uses algorithms and models to analyze historical and real-time data, identify patterns, and predict potential issues. When applied to failure prediction, ML models can analyze the performance data of machines and systems, detect anomalies, and forecast the likelihood of a breakdown. Here's how ML transforms failure prediction. 1. Data collection and integration. Machine learning models require a wealth of data, including sensor readings, historical maintenance records, environmental conditions, and machine usage patterns. By collecting data from IoT sensors, SCADA systems, and other industrial data sources, organizations can provide the raw input for ML algorithms. The data is then cleaned, labeled, and integrated into a central system for analysis. This preparation is key to building accurate models. 2. Feature engineering. Feature engineering involves identifying and selecting key data attributes that most influence machine failures. For example, in a manufacturing plant, temperature variations, vibration patterns, and energy consumption might be critical indicators of a potential failure. By focusing on these features, ML models can become more accurate in predicting failures. Feature engineering requires domain knowledge and collaboration between data scientists and maintenance engineers to pinpoint these variables. 3. Model training and testing. Machine learning models are trained using historical failure data to understand patterns that precede breakdowns. Supervised learning algorithms, like decision trees, support vector machines, SVM, and deep learning models, are often used for this purpose. During the training process, the model learns from past failures, identifying the relationships between input features and the likelihood of a breakdown. The trained model is then tested using a subset of data to evaluate its accuracy and ability to predict future failures. 4. Anomaly detection and real-time monitoring. Once trained, ML models can be deployed for real-time monitoring of equipment. They continuously analyze data streams, comparing them against learned patterns to detect anomalies, signals that deviate from normal operating conditions. For example, an unexpected spike in vibration levels or temperature could signal a problem with a motor. The ML model can flag this anomaly, alerting maintenance teams to take preventive action before a failure occurs. 5. Predictive insights and maintenance scheduling. By predicting the remaining useful life, RUL, of equipment, ML models enable organizations to schedule maintenance only when it's necessary, reducing the frequency of unnecessary checks. This allows companies to optimize resource allocation, minimize downtime, and extend the life of their machinery. It also helps in better inventory management, as spare parts can be ordered only when needed. Key machine learning techniques for failure prediction. Several ML techniques are commonly used for failure prediction, each with its strengths. Regression analysis, useful for predicting the time until the next failure by analyzing continuous variables. Classification algorithms, these include decision trees, random forests, and logistic regression, which can classify whether a machine is likely to fail within a certain period. Neural networks, deep learning models, like recurrent neural networks, RNNs, and convolutional neural networks, CNNs, are effective for processing time series data and detecting complex patterns. Anomaly detection models. Techniques like autoencoders and isolation forests are designed specifically to identify deviations from normal behavior, making them ideal for early detection of failures. Real-world applications. 1. Manufacturing. Factories use ML to monitor CNC machines, robotic arms, and conveyor systems. By analyzing vibration data, pressure readings, and operational cycles, ML models can predict when parts need replacement. 2. Oil and gas. Predictive maintenance is crucial in this industry to prevent costly equipment breakdowns and potential safety risks. ML models analyze data from drilling rigs, pumps, and pipelines to forecast failures and avoid unplanned shutdowns. 3. Aerospace. Airlines and aircraft manufacturers utilize ML to predict potential failures in engines and other critical components, ensuring flight safety and reducing maintenance costs. 4. Healthcare equipment. Hospitals use ML to monitor the condition of critical medical devices, such as MRI machines and ventilators, ensuring they are always in optimal working condition. Benefits of using machine learning for failure prediction. 1. Reduced downtime. By predicting failures before they occur, businesses can plan maintenance activities around production schedules, minimizing unplanned downtime. 2. Cost savings. Avoiding catastrophic failures and extending the lifespan of machinery can save significant costs on repairs and replacements. 3. Enhanced safety. Early detection of equipment issues helps in mitigating safety risks, protecting both workers and the environment. 4. Optimized resource utilization. Maintenance teams can focus on critical tasks, reducing time spent on unnecessary inspections and routine checks. Challenges in implementing machine learning for failure prediction. While ML offers immense potential, there are challenges to consider. Data quality. ML models require accurate, high-quality data for effective predictions. Poor data can lead to inaccurate models. Model interpretability. Understanding how an ML model makes predictions can be complex, especially with deep learning models. This can make it difficult for maintenance engineers to trust and adopt ML-driven insights. Integration with existing systems. Incorporating ML models into existing infrastructure can require significant investment in terms of time, money, and expertise. Conclusion: embracing the future of maintenance. The application of machine learning in failure prediction represents a significant leap forward for industries striving for efficiency, reliability, and safety. As the technology continues to evolve, businesses that embrace ML-driven predictive maintenance can expect to see enhanced productivity, reduced costs, and a competitive edge in their respective markets. With data as the foundation, the future of failure prediction is not just about fixing issues, it's about preventing them from occurring in the first place. We hope this information has been useful. Thank you for watching. If you found this video helpful, don't forget to subscribe to our channel for more informative content. For more details, visit our website, fogwing.io. We look forward to seeing you in the next video. Until then, take care.